Hi all. In this session, let's learn about process control block. Every process in an operating system is represented by process control block or PCB. The PCB is also called as task control block or TCB. Think of PCB as an ID card or a record file for a process. It stores all the important information of the operating system needs to manage that particular process. Whenever a process starts or resumes after being interpreted, the operating system uses the information stored in process control block to continue its execution from where it is stopped. The PCB also keeps information such as process ID, CPU time used, and other resource usage details. In simple, the PCB is a data structure that stores everything the operating systems needs to create, manage, suspend, resume, and terminate a process efficiently. Now let's look out the different fields stored inside the process control block. Now let's check out the main components of process control block. Each component stores specific information about a process. The first component is process states. It tells us the current state of a process. A process can be in states like new, ready, running, wait, and terminated. The second component is program counter. It stores the address of the next instruction to be executed. This helps the operating system continuing the process from the current point. The next component is CPU registers. These registers stores the temporary data that the CPU needs while executing a process. They include accumulator, index register, stack pointer, general purpose registers, and condition codes. Whenever the process is interpreted, these values are saved and later restored so that the execution can continue without any loss of information. The next component is CPU scheduling info. Here, it contains a priority and scheduling details. The operating system uses this information to decide whether the process should get the CPU next or not. Next, we have memory management information. It stores the detail about the memory allocation to the process, helping the operating system manage memory efficiently. The next is accounting information. It keeps the track of details such as process ID, execution time, and so on. So this information is useful for monitoring the system performance and resource usage. Finally, we have IO status information. So it stores the information about the input and output resources used by the process, such as allocated devices, open files, and whatever the resource allocated to the process. So these are the main components of the PCB. So together they provide all the information the operating system needs to manage, schedule, and execute the process efficiently. Now let's understand the process control block using this simple example, that is Google Chrome browser. Suppose if you open Google Chrome on your computer, the operating system creates PCB to keep track of everything about this Google Chrome process. First, we have the process state. Here, the state is running, which means Google Chrome is currently executing in the CPU. The next is program counter. It shows the address of next instruction that CPU needs to be executed, and the example address which is to be executed by the Chrome is given here. After that, we have CPU registers. The registers store the temporary values that CPU is using while executing the Chrome. For example, here the register R1 holds 10, R2 holds 20, SP holds a value 1000. Next, CPU scheduling information. This tells the operating system how the process should be scheduled. In this example, Chrome has a priority of 3 and it gets a 10 millisecond time slash before the CPU switches to another process. The next is memory management information. This stores the detail about memory allocated to the Chrome. Here, the code uses 100 MB, data uses 250 MB, and the stack uses 2 MB. Next comes accounting information. Here, it keeps track of resource usage. It shows the details such as process ID, that is 2548, and the CPU time used, which is used just 12 seconds. Finally, we have IO status. This shows that input and output devices being used by the Chrome. In this example, keyboard and mouse are active. We can see that keyboard is equivalent to active and mouse is also equivalent to active. The network is connected because the Chrome is accessing the internet. So network is also connected. So the PCB acts as an information card for a process. It stores all the important details the operating system needs to manage and schedule. And it also executes the process efficiently. So hope you are clear in PCB with this example.
Thank you all.